Okay, take it everyone can hear me, and hope you're all expecting the art of benchmarking, separating fact from fiction. Quick preamble, there is the Slido thing. Hopefully everyone's familiar with how to get to the right page by now, and we're in room 11. A quick who am I to begin with. So I'm Nick, I'm Palmer on Twitter. I'm Palmer without an E on GitHub. Not very active on Twitter, but if people want to tweet me and get responses, I do that. If you've looked at the speakers page, you'll know that I'm a holder of chickens. And in my spare time, I'm a sailor of seas. Although I'm not a C programmer, I'm mostly a JVM developer for the past kind of 16 years. And in those past 16 years, probably the last 8 or so have been in the low latency, financy world. Bouncing around. Lately I'm writing Scala. Another thing to know about me for this talk is that I was previously a maintainer of the LMAX disruptor, which is a high performance kind of inter-thread messaging library. Used in various places like LMAX. It's also used by the async logging in Log4j for doing that kind of high throughput, low latency where performance kind of matters. It's also worth mentioning I have a little bit of a cold maybe, so if there are some sniffles, I apologize. So benchmarking for me starts here. The year is sometime in the 90s, I think. Went to London, and in Trafalgar Square there is this wonderful statue of King Charles I, looking wonderful in bronze, I guess, on a nice, I think it's carved limestone plinth. Round the back of the plinth, I saw this. And I was like, well, graffiti is normally done with pen or spray can, not many chisels and hammers going in the graffiti world. What on earth is this mark? I asked my dad. And he knew what it was. And this thing here is what's known as a surveyor's benchmark. And more specifically, this line at the top is the benchmark. This thing underneath it, that's an arrow pointing to the benchmark. And this is kind of where benchmark comes from, because this mark, that line, is where a bench, a metal right-angle bench, gets put into. And on top of that mark and that bench, they then hold a stick with various lines drawn on it. And if you have 2 of these in 2 different places, you can compare the relative elevation between them. And so that's what a benchmark is. Thank you for coming. Here we go. So yeah, this is used for comparing elevation from one place to another. If you're in the UK, you've probably seen these. You might not have even noticed it, but they are everywhere. There is a map online where you can find all the benchmarks. There are some near you. They are typically carved. Sometimes they're a metal plate. Sometimes it's a metal point or a metal sheet. All over the UK, a lot of UK-related countries, so New Zealand, Australia, Canada, have these everywhere. France has quite a lot. They're well known for their mapping. If you know about some king back in French history wanted to know the size of his domain, and people went out for years triangulating to find out how big France was. So they're also quite keen on the old benchmarks. Your country may vary. And it's not just fancy statues. They're on all sorts of walls in the UK, so if you haven't noticed them before, next time you're there, look out for your nearest benchmark. So that's great. Probably not too relevant, though. What is the meaning of a benchmark? Well, it is what that thing is. It is a point of reference against which other things can be compared. So if you have 2 benchmarks, you can then compare the relative elevations. If you have more benchmarks, you can compare, and you can end up getting an elevation map of some land, a country, whatever. But this also applies to software. So in software benchmarking, there are various things you can measure and various ways you can measure. Micro-benchmarks is probably the one most people think of, especially in the Java world, when they come to doing low-latency benchmarking. So micro-benchmark is very small, focused on kind of an individual method, code segment, single function, maybe a loop. And you would use micro-benchmarks when you are optimizing a tight loop. You're optimizing a function. So say if you've got two ways to concatenate strings. You might test out which one is fastest or uses the least amount of memory, or the most if you want, using a microbenchmark. Hash functions, there are many ways to implement a hash function, and you can compare them with a microbenchmark. You've got kind of macro benchmarks, or kind of end-to-end general testing for latency. That's where you're testing your entire system, or at least very large subsystems of it. You're measuring typically end-to-end application performance. So think about, I send a request to a web server, I get a web response back. How long did that take? That's kind of your macro benchmark. You've got synthetic load. So if you have a web server, you might want to see how it handles 1 request a second, 10 requests a second, 1,000 requests a second, 1,000,000 requests a second. And you would just keep on pumping events into the system and measuring the latency. And typically, you get to a breaking point somewhere where queuing happens or back pressure, and your latencies will go up. So there are tools for this. If you're a Java person, you might have heard of Apache JMeter. That's kind of a synthetic load testing tool. There's Sysbench for databases, and you might write your own. You can do real-world replay. So that synthetic load is a constant load. But most applications, a web server, I've worked in financial exchanges, they're quite bursty. There are long periods where nothing happens, and then in a millisecond, suddenly 800,000 people want to come and trade. If you do synthetic load, you're not really going to test that. Real-world replay, you can record the events going into a production system for a minute, an hour, a week, and then you can just play them back into another system running in CI and see how that performs. So that'll give you more realistic production-like scenarios. Obviously, you need to occasionally refresh that real-world data as your customers, your platform moves on. You've got regression benchmark tests. So a common example is a microbenchmark. You might be testing a matching cycle of your financial trading engine. As you do commits over the years, the performance of that function is going to change. Has it changed for better or for worse? If you release every 2 weeks and you do 1,000 commits between each release, is it going to be good when you release it or not? You might want to have continuous profiling in CI and Jenkins that checks those tests. So it's the same test, but with different code. And see how that moves over time. And you've got general comparative benchmarks. So am I going to use Aaron or am I going to use Kafka? Am I going to use this JSON parser or that JSON parser? I might care about memory usage of those. I might care about CPU performance. I can use benchmarks to compare between the two and see which one I think serves me best. And so a micro benchmark, you might create one. Here's one I'd done a while ago on the different ways to get the time in Java, because that was important to me at the time, and looking at GC allocation rates, because some people had thoughts about that. And so if you run a micro benchmark, this is typically the output you get. It's a big table of numbers. You can choose what the measurements are. So here I'm doing, I think it's nanoseconds per operation. So how long does it take me to get the time? So who watches the watchman kind of thing. It's a big old table, and you can see on here I've got different ways of doing it. So I'm using instant.now, I'm using current time millis, I'm using FFI, all different ways to do the same thing. Which one's quickest? Here's an example of kind of regression testing. So I've got a micro benchmark, and I've been running it continuously. I'm going to guess that somewhere around here, someone committed and then went to lunch. Maybe they didn't commit the best code. Who knows? Because we can see that performance has shifted considerably. And later on, they probably realized and they've done a revert. So they brought it back into line. So this is the kind of thing that you would want to check before you take a release candidate for release. Is my code in this state? Probably don't want to release it. Might want to wait until the revert goes through, check everything's back to normal again. Macro benchmarking, kind of a nice way to visualize this is histograms. Big fan of a histogram, especially the HDR histogram library from Gil Tenner from Azul. And this is kind of a render of a HDR histogram. The data on here is not mine. It's just one taken from their GitHub. But it is kind of an example where you can see, okay, what are my 4.9's latency? And you can go up and read across to see what the latency is in milliseconds. And you'll note that sometimes there's a bigger increase, or there might be step changes going on. That can give you information about queuing and back pressure that's happening deep inside your system. So yeah, wonderful charts, benchmarking. There's lots of ways to do it. Are there any problems with this? Or shall I just go home, let you all go to the pub? No, I'm sorry, there are problems. Benchmarks can be misleading, especially ones that you haven't written. So typically, you might see benchmarks from a manufacturer, a salesperson who is trying to say how great their thing is. You should use us because we are 25% faster than the competition. Anytime it's coming from a marketing department, you should already be slightly on edge. It's very rare for these people to just outright lie. However, you can cherry pick your results. Maybe they run it 10 times and they just pick the best. Maybe their competitors, they run 10 times and they pick the worst. Who knows? What are they actually showing? They might have poor statistical practices. Maybe they're just using an average, not a histogram. Probably not great. At least use a median, better than an average. They might also do some subtle deception, like configuring their thing, their tool, in the most optimal fashion. And then all their competitors, they just leave with default config and say, look how much better we are after we spent 2 days tuning our system and no time at all tuning anybody else's. And there was a talk recently, I think in January, by Francisco Negro, known as Forked Franz on GitHub and Twitter. He's a very good performance guy, I think works on Quarkus. And he did a talk at Devox about benchmarketing and the various dodgy things you can see in there. Highly advise anyone who's interested to go and watch this talk. Other ways a benchmark might be misleading. Equivalence. Are you comparing apples to apples, or is it apples to oranges here? If you're comparing a web messaging framework versus an ultra-low latency messaging framework, probably the ultra-low latency messaging framework is going to be better, but it's going to be a lot more restrictive in what you can do with it. It's maybe not designed for web tools or taking JSON in. The debugging's potentially going to be harder. When you're looking at these things, how realistic are the inputs? If they're comparing two different things, the inputs might be very favorable to one of the frameworks and very unfavorable to another. Something's geared towards sending lots of very small messages versus a few large messages. What are the inputs when they're benchmarking it? And a classic, obvious way, although you never notice it at the time, you think you've done a really good job, not testing what you thought you tested. So if you write a JMH benchmark, never trust the results. Always dig in. You should never write a benchmark, run it, get a result, high five, go to the pub. You've always got to have doubt and trust, but verify. Because what if your code was optimized away? The Java JIT, JVM JIT, is very good. If it thinks it can, it will get rid of code and make it run really fast. Might not actually be fair to what you're benchmarking. So you've got to be careful with these things. And lots of people fall into that trap. So developing your critical eye, code. If you see someone post a benchmark and they don't post the code, don't trust it. Why? You could have just made those numbers up. It's completely unreasonable. Context. If they do publish the code, that's great. Can you replicate the results? Probably not, almost all of the time. What hardware did they run it on? What CPU, what RAM, what disk, what NIC, depending on what hardware it's touching. What OS was it running on? What version of that OS? You know, the Spectre and Meltdown patches for Linux, that changed a lot of benchmarks. What language runtime or compiler options? If it's Java, there's a lot of flags you can give the JVM on startup that will get you very different results. If you're doing something that's very CPU bound, which is kind of what I've done more in the past, things like BIOS options can be really impactful on that. And thread pinning, especially if it's a CPU bound benchmark, what cores are your threads running on in your benchmark? If somebody doesn't share that, there's going to be no way you can replicate. And this is made probably a bit more tricky in the modern world with things like Zen, because that has a multi-chiplet architecture on some of the CPUs. So you then end up with NUMA-level cache differences, where if you pin your threads at the far ends of the CPU, it's going to be far slower than if you pin them right next to each other, where they can share an L2. And charts is something else to look out for. If you're tuning your critical eye, they're a great way to mislead people. And this is probably where the marketers really get to flex their skills. So I've seen benchmarks where they publish two charts, one of their results and one of competitors' results. That to me is an obvious red flag that why didn't you put them on the same charts where you could easily compare between them? If they're in two separate parts of the page, I have to scan back and forth. Have they done some other sneaky things? You can offset your axes. You can scale your axes different. Maybe one is a log scale, one isn't. Who knows? And depending on the type of chart as well, you know, bar charts, pretty good. Table of numbers, great. Pie charts, the worst. Does anyone here like pie charts? Good. So examples here of charts. This is the exact same data. But if you don't look at it and have a little think, you might say, oh, the one on the left, A, is way faster. And the thing that they tested on the right, A, it's about the same. Now, these are the exact same charts. I've just offset the axes a bit to make the difference obvious. Pie chart. Okay. One of these segments is 15% different to the others. Who thinks they can spot the small segment? Anyone think it's A, B, C, D, E? I don't remember how many you put on that E. It is D. It is D. So D is 15% different. All the others are within 1% of each other. But this chart, you know, the amount of charts I've seen like this, terrible. It's really good if you want to be a marketer and fudge some numbers, but if you want to convey information, just don't ever do a pie chart. Another example of something I would say very pretty, doesn't really convey much information, is this. I don't know if people saw this, that there was someone on Twitter, it was all the rage, end of the year, January, around the time I submitted this talk, about this kind of benchmarking performance between different languages. And I think if I escape, I have this thing going. And look at this. It's really cool. It is quite cool. But does this tell you anything? Does this really say that, you know, Scala is way worse than Go? Or no, better than Go. Sorry, it's faster. It's way faster than Go, Scala. Maybe. What is this doing? And this is not so bad, actually, because they have published the code. This is what they're doing to benchmark different languages. Okay. Yep. I think you can probably cast your own judgment on whether you think that's a good reflection of the language. Let me just try and get back to speak view. And if you want more thoughts on this, which I highly agree with, there is a video language performance comparison to junk by the Primogean and Casey Moratori, who always have good things to say on performance. So the other thing is what matters to you is quite important. Some of these benchmarks might show really interesting results. it might show that something is faster. Does that mean you have to use it? No, probably not. Another example I'm going to try is this. So did anyone here do the billion row challenge? See, a couple of years ago now, there's a few hands. So this is kind of the default implementation, which is incredibly slow. So if I take my mouse over, and here on this side is a much faster implementation. And this benchmarks way better. Do you want to maintain this? Or this bitwise math, or these ands? Like, this is much better. Much better. But it might not be for you. Do you need this? Is something that you should be asking yourself when it comes to that. So we've gone through some of the art and some of the deception. What about some science? Bring us back to more computer science friendly topics. How are we going to do some benchmarks? So I kind of mentioned JMH. This is the Java Micro Benchmark Harness written by Alexei Shipilev. It's on the OpenJDK GitHub. It's really good. It takes away a lot of the troubles you can get into with measuring things yourself, especially when you get down to very small measurements. So it will handle things like warm-up for you, so running the code a whole bunch of times, not measuring it, just to make sure that the JIT has got everything nicely compiled. It's great. Highly advise people give it a go. I think I've got an example, hopefully. So for people who haven't seen a JMH benchmark, you should have gone to Ryan's talk yesterday, because he did show on the screen. But this is the kind of thing, and one nice thing about it is that you can kind of codify how many warm-up iterations, how much measurement, what are you measuring here, what are your units? It's all in the benchmark. So anyone who wants to replicate this should very easily be able to replicate it. You can then, I'm not gonna run it, because that'll take a while. But some interesting things, you can add profilers to it. So I mentioned earlier that maybe you aren't testing what you think you're testing. A good way to tell is to add extra profilers. So when this runs your code, it will, I've got perfasm, so it will dump the assembly of the JITted code that it compiled. So when I was doing the clock, getting time sources earlier, that was quite useful. Like, I know that there's a VDSO bit of memory in Linux, and it can get the time from that. How is it actually doing it? Put perfasm on there, get the assembly out. It's great. You do have to look at assembly, so you've all been warned. You can also add perf. So this benchmark here is kind of testing. Does anyone here know about false sharing? No? So if you went to Ags's talk a few minutes ago, there was talk of cache lines. So you've got cache memory, but it tends to be in chunks, cache lines. That cache line can be 64 bytes, can be more, depends on your architecture. If you've got two longs, say, next to each other in a class, they might be in the same cache line. If I've got two threads that are updating those longs independently, every time it updates, that information has to go to all the other CPU cores. And that can cause performance issues, even though you aren't really doing anything with that memory. So you're sharing it, but you're not false sharing. And this is a test for that. That's going to be very kind of CPU cache specific, so I've added the perf profiler on there, and anyone who's used Linux perf before will know you'll get stats about cache hits, cache misses, different cache levels. It's really useful. So yeah, JMH is a great way to write some micro benchmarks. If you want to find out more about JMH, look it up on YouTube, or more importantly, go to the repo. If you go to the repo, there is a JMH samples folder in there, which has a bunch of examples, and that is their kind of documentation. It's kind of working, living documentation. Potentially, you want to do that macro benchmarking end-to-end, and JMH is maybe a little too fine-grained for that, for what you want to do. So you're going to write it yourself. All you need to do is take a note of the time, do something, take another note of the time, subtract the two, latency measurement. However, you do need to do a bit more than a couple of system current time millis around a loop and printing out an average. So I do have here, hopefully. So here is a couple of system current time millis around a thing in a loop. Can anyone tell me any problems with this? It uses average. That is indeed a terrible, terrible thing. Anything else? No? Okay. Well, there are a few things I would say here. So average, definitely not going to give you much information and can really skew. You're not going to know about your kind of long tail or anything. Speaking of long tail, I'm only running this 10 iterations. So I'm not really going to get the best information out of it, even if I did have a histogram. You know, if I want 4 nines out of the histogram, I need to have at least run this 10,000 iterations. Other problems, it's using current time millis. What if NTP decides, hey, your clock needs updating, you were a few seconds out? You're going to get some very weird results. So you want to use a monotonic clock. And these are all things you can do. So stick in a monotonic clock, bump up the run count, do something like with a proper histogram instead of just an average. That will be better. But you're likely to fall into a lot of other traps, which I won't go into too much detail for time. But I would highly advise anyone to watch this talk, How Not to Measure Latency by Gil Tenner from Azul, the man of HDR histogram fame, which I professed my love for earlier. He also did this talk, which is a really, really insightful and quite wide-ranging talk on how you can think you're measuring your latency and get very inaccurate results. And there's this concept he talks about, coordinated emission. So that's where maybe you have this load generator, that code I showed before, you know, it's hitting some system under test in a loop and it's timing it. What if the load generator stalls or gets back pressured? Your timings are just going to say, yeah, okay, I'm not timing anything right now, I'll wait until the next iteration. So you end up with this kind of completely great looking histogram where everything's super low latency and it's amazing, but it's all a fiction, I'm afraid. So yeah, there's another talk that is a lightning talk just about coordinated emission by Paul Naumann, who's also from Azul. If you're ever thinking of writing this kind of code yourself, you should definitely go and give these talks a watch. If you don't want to write this kind of thing yourself, you can use Apache JMeter. I've never used it myself, so I can't comment on it. But it is for kind of load testing functional behavior. It was originally written for HTTP kind of testing, so testing your web servers and so on. But now it can measure all sorts of things. It also used to suffer from coordinated emission. So the way that JMeter was measuring things had an issue in it, but that has now been solved. So if you use JMeter, you won't fall into the same bear trap. And finally, when it comes to benchmarks, you want them to be reliable. You want them to run and give you the same answer time and again. If they're giving you different answers, it's not going to be very useful for you. So you probably need dedicated hardware for benchmarking. If that is continual in CI, you need a box that is just doing benchmarking. You don't want halfway through the test somebody going on there and downloading a bunch of stuff or running a Bitcoin miner and gobbling up all the CPU. If you're doing these benchmarks at home, you probably don't want to be doing it on a laptop. You're going to hit thermal limits. If you want to do thread pinning, it's probably unlikely you've set up isolated cores on your own home machine, because there's a bit of a waste of all that money you spent on the CPU if you do that. So yeah, you kind of need a dedicated machine, and that machine should only really be running your benchmarks when it is running your benchmarks. The tuning on there should be consistent as well. So if you are doing any thread pinning, same threads every time. Environmental stability. So with that machine, if it's a laptop, literally the environment is unstable. It might get hot. That's not great. So thinking about temperatures and so on, your operating system version that we kind of mentioned earlier in the context, if you do operating system updates, it might change your performance, even on a small little micro benchmark. If you update Java, you probably need to go and rerun all of your benchmarks. What you can't do is benchmark 10 things, then update Java, and a week later benchmark one more thing and try and compare them. It's not fair. It's not comparing apples to apples. The equivalency goes. So having that stability is quite important. And the noise floor, I kind of mentioned earlier about being able to get consistent results out. If you're measuring something in the seconds is your latency, then you've got quite a bit of room to maneuver. You can have fairly fluctuating results, and it's not so bad. If you're measuring something that is nanoseconds or microseconds, a couple of nanoseconds here or there because your computer decided to do something else, that's going to throw your results off massively in the single-digit percentage points. And really, you want your noise floor to be below 1%. Otherwise, the results are not all that reliable, not all that trustworthy. So in conclusion, if you're reading other people's benchmarks, take a heavy pinch of salt, unless you think you can reproduce, unless they give you all the information about how they did that benchmark. Why are they doing that benchmark? What is this person's motivation? Consider that. Look at the charts, if there are charts. Do you trust the way they've presented that data? Have you checked, are the axes labeled? Are the units there? And then if you're writing your own benchmarks, are you running them in a consistent, reliable way? Have you checked that it is actually benchmarking what you think it benchmarks? If you think there's queuing when you see one of those histograms with that kind of double bump on it, do you have metrics around the queuing? Are you confirming that? You're not just assuming, well, the benchmark looks like it's queuing. Go and have a look and keep an eye on all of that. And yeah, that's pretty much it. Ready for questions if people have them. Which they do. Okay, so JMH is good, but how should one analyze the collected data from CI runs? Any good visualization, any tool to automatically discover regressions? As far as I know, no good tools out there. When I was at LMAX, we had kind of internal tooling that we'd written, so it would run the benchmarks, and JMH can give you the output in various formats. You can get it in like XML or JSON. You can consume those files, shovel it into a database. Once it's in a database, you can, in years gone by, write your own front ends to plot them. So that little chart with the step change earlier, that is that. These days, if I was doing it, I would still shovel data into a database. I'd probably use Grafana on the front end. Grafana is very pretty. I love it. It makes charts very nice to produce, and almost anything looks good. You can also make them dynamic. You can link them and share them to people. So Grafana is really good for that. In terms of automatically discovering regressions, I think Grafana's got tools like Alert Manager. I don't know if anyone is a Grafana user here who knows better than me. There are things in Grafana for alerting you to general changes, right?
It's not so much Grafana as the backend, so Prometheus or whatever you're running on top of.
Yeah. Okay.
It's a good toolkit for that.
Yeah, so maybe if you put your data into Prometheus and then use Prometheus's tools, Grafana to visualize it, you can get automatically discovered regressions. In the past, the way I've done it, you just go and eyeball it before a release and cross your fingers, cross your toes, hope for the best. How to benchmark and have stable results on the cloud machines. Can have different CPU at the same time. Yeah. Only recently, in the past 6 months, have I been living in a cloud-based world. Before that, I have been dedicated hardware, bare metal, everywhere, where we go and buy the physical machines and put them together by hand, artisanally crafted. In a cloud-based world, Yeah, I don't know. You can buy dedicated machines on AWS where you're not going to get booted off and time sliced. I think if you are running benchmarks in the cloud, you definitely need one of those machines. Don't be using the cheapest EC2 instance. You need a CPU where you aren't going to be booted off. If you do run in the cloud and you see that you've got unstable results, maybe your noise floor is quite high, you can dig into it. There are tools in AWS to tell you, you've been booted off 20% of the time. I think you can see that in Top and various other tools. So yeah, it's one of those things, if it's in the cloud, it is going to be tricky. Yeah. Something I forgot to mention, actually, if you do have a dedicated machine, you should try and make it somewhat respective to production. So if you're running on AMD CPUs in production, but you run all your benchmarks on a new MacBook running an ARM CPU, don't. Your mileage will vary. It may be correct, but the new ARM CPUs on the Apple laptops are really good. It might tell you something is better than it actually is when you run it on x86. So yeah, and in AWS, you've got the Graviton instances. They're quite cheap. You might want to run things on there, but if that's not what you're running in production, probably don't use the same instance that you would run in production. Have I also watched the tutorial of how to pick up a duck? I have not. Picking up a chicken was one thing that I'm skilled at. Picking up ducks, I'm afraid not. If anyone wants to send me that tutorial, I will happily watch it. And if I come again next year, I'll bring a duck and pick it up. For now, I'm unskilled, untrained. How is regression testing different to the other types, plus tracking over time? So yeah, regression testing isn't really different to the other types. It's the way you use it that is different. So JMH, you run JMH over and over and over. That's your micro benchmarking. If you keep those results and then look back at them, that's kind of regression testing. The same way you can do it for macro benchmarking or the other types. So regression testing in and of itself isn't really a thing. It's just you're not comparing code change to code change, library to library. You're comparing history of code changes and plotting them and making decisions based on that. And yeah, tracking over time, that is the regression part of it. All charts can be distorted like the pie you were shown by drawing in 3D. Yeah, 3D charts. It's the word art, and it still carries on to this day. I still see them. Why exactly do you dislike pie charts? People are really bad at being able to judge the relative area of kind of pie-shaped things, those slices. It's just not something that people are good at. We're quite good at seeing this number bigger than that number, or this rectangle taller than the other rectangle. But the second you get into angles, especially if your pie chart is unlabeled, it's really hard. If you do put labels on a pie chart, you can say, what the percentages are. So I could have done that earlier, and it would have been really obvious which one was the small one, because, hey, it would say. But if you're doing that, well, you could have just shown the numbers, and the pie chart is just visual candy. It's not conveying meaning in a good, useful way. There are many other people like me. I'm not the only pie chart hater in the world. Feel free to Google it. There's a whole society of us. And yeah. How do you benchmark the benchmark trustworthiness? Top aspects, metrics of the benchmark results, and not deceiving yourself. So yeah, trust but verify is probably the way to go. So you never really trust it. You always have to look in. If I'm writing a JMH test, I probably will be looking at the assembly at least once just to check it's not jitted everything out. I might make some slight variations of the thing I'm benchmarking and see, okay, if I tweak it in this way, which I think is going to be obviously worse, does it react in the same way? If it does, I'm probably measuring the right thing and it's reacting in the way I think it will. Kind of metrics as well, I mentioned with the more macro style end-to-end. If you think your synthetic load is going to cause some queuing, you can look. Hopefully your cues have some metrics that go into Prometheus so you can see them in Grafana. Do you see that queuing? How big is that queuing? Is it what you expected? Is it too much? Are messages getting dropped? That's something I've seen before. Got great performance. We sent 1,000 messages, 2 came through, but those 2 came through really quickly. So yeah, it's always got to take it with a pinch of salt, double check, potentially try and just break it and see if it breaks how you thought it would break. If everything's going well, never believe it. So if you write a unit test and it goes green first time, don't do that. Don't commit it and go home. No, you've got to break that unit test, see that it goes red, and it goes red for the right reason, and then you can fix it and make sure everything's good. So those are my tips for not deceiving yourself, is just never be confident in yourself. Always doubt yourself. Never think you've done a good job. You'll be on the right track. How to avoid benchmarking instrumentation to influence the real results. Yep, that's definitely a thing, especially in the micro-benchmarking world. So earlier on, I had the kind of micro-benchmark results of getting the time. But if all I'm doing in my kind of measured system under test is getting the time, and we know to measure the latency before and after the test, it's going to get the time, you can see that there might be issues that happen here. So things you can do to avoid your benchmarking instrumentation influencing the results. Maybe you can get the time in your test maybe 10 times, and that gives you, a 10 times multiplier on the impact of what you're doing, so that your thing that you're measuring is more impactful than the benchmark harness. That's not a great way. The best way is just to look at it and see, is your instrumentation influencing it? If it is, it's kind of case by case. But I'm not sure if there's really a good answer. If anyone knows a better answer, feel free to shout out. No, my hand waving was good enough. Okay, cool. I think that is it.